in this video we are going to learn how to solve modulus inequalities. There are two properties that you need in order to use to solve these types of equations, which are when modulus of x is less or equal to a, it is equivalent to say x is between a and negative a. The other property is when x modulus of x is greater than a, then it's equivalent to say x is greater than a or x is less or equal to negative a. Now, as an example, I'm going to solve this inequality. 2x minus 5 is less than 3. Now, here, as you see, the first property must be implemented here. So it is equivalent to say 2x minus 5 is less than 3, greater than negative 3. Now, to get rid of negative 5, 5 is added to both sides, so it would be 2x is between 8 and 2. Then, in order to get rid of 2, both sides, all sides divided by 2, it would be 1x 4. It is the final answer. Now, there is another alternative to use. Now, alternative 2, you can use another alternative to solve such inequalities. Now I rewrite the inequality modulus of 2x minus 5 is less than 3. As we are not sure whether 2x minus 5 takes positive values, negative values, where it takes positive values, where it takes negative values, and it is inequality. Inequality, we know that when it is, for example, when you divide or multiply both sides by positive, the direction won't change, but when it is divided or multiplied by a negative number, it will change. So we don't know what values this expression is going to take in different intervals. So before we know that before and after critical values or root of this expression, the behavior will change from positive to negative or negative to positive. So to make sure that they are both non-negative numbers, so I easily square both sides. So it will be 2x minus 5 squared less than 9. Now I use the second identity formula to expand this expression. It would be 4x squared minus 20x plus 25 less than 9. Now it would be 4x squared minus 20x, 25 minus 9. It will be 16 is supposed to be less than 0. Now, as you see, all terms are divisible by 4, so I divide by 4, and as 4 is a positive number, the direction won't change, so it would be x squared minus 5x plus 4 less than 0. Now you have a quadratic inequality. We already learned in AS level how to solve quadratic inequalities. First step is to solve corresponding equation. So it will be x squared minus 5x plus 4 is equal to 0. If you factorize it, it will be x minus 4, x minus 1 is equal to 0. Then x will be 4 or 1. These are the roots. Now I construct a sign table x, and here x squared minus 5x plus 4. I write the roots in order, ascending order from smallest to the largest, 1, then 4. Here it takes the value of 0 as it is the root. Now x squared minus 5x plus 4 is a curve bending upwards. So it is the first root, it is the second root. Before the first root, it takes positive values, so it would be positive. Between the roots, it takes negative values. And after the second root, it takes, again, positive value. But the question wants, the corresponding inequality was x squared, this inequality, x squared minus 5x plus 4 less than 0. So we need the interval in which it takes negative values. So x is between 1 and 4, the same answer as we got in the previous case. Now, let's see another example. Now, as the second example, we are going to solve the inequality modulus of 2x minus 1 is greater or equal to modulus of 3 minus x. Now, as again we have two modulus in both sides, and we cannot easily remove these modulus as we don't know what values they are taking in different intervals, maybe positive, maybe negative, and we know that negative values will create problems because they may cause change in the direction. So to resolve that problem, I easily square both sides. Now, so it will be, then you can remove modulus. So it will be 4x squared minus 4x plus 1 is greater or equal to 9 minus 6x plus x squared. Now I transfer whatever term I have to one side. It would be, and after simplification, it will be 3x squared plus 2x, 1 minus 9, which is negative 8, is greater or equal to 0. Now, as we are going to solve this inequality, which is, this power 2, we need to first solve corresponding equation. 3x squared plus 2x minus 8 is equal to 0. I first find the corresponding discriminant. It would be 4 minus 4ac, which is 4 plus 4 times 3. It will be 12 times 8, 96, negative, negative, positive, so it will be 100. As it's positive, so it will give you two distinct real roots. X is equal to minus b plus minus radical delta over 2a, which is equal to minus 2 plus minus 10 divided by 6. So once considering negative, it will be minus 2 minus 10, which is negative 12, divided by 2 will be negative 2, the first root. The second root, minus 2 plus 10, which is 8. So it will be 8 over 6, which simplifies to 4/3. It is the second root. Next step is to go for sine table x, and the standard inequality which is required to be solved is 3x squared plus 2x minus 8. I write again roots in order, so minus 2 is the first root, 4 over 3 is the second root. It takes 0 value here. Now let's decide about sine in different intervals. So it bends again upwards. So before the first root, it takes positive values. Between the roots, it takes negative value. And after the second root, it takes again positive values. But we want this expression to be greater or equal to 0. So the intervals in which it takes values greater or equal to 0 is x less or equal to minus 2, this interval, and this interval, or x is greater or equal to 4 over 3. This is the final answer. Thanks for watching this video.